Acceleration is defined. Acceleration is how fast your velocity is changing or how fast your speed is changing. Don't underline this, I'm just going to, it's the rate of velocity change per second. What the heck does that mean? Well, first of all, Robert, for Physics 11, we have to look at a constant acceleration. We're going to let you step on the gas or step on the brake, but once you step on the gas or step on the brake, we're not going to let you step on it more or less. Okay? If you have a changing acceleration page, you really need calculus. It's difficult to do anything without calculus. But we can do some really good stuff with constant acceleration. Thankfully, there's some really neat applications that have a constant acceleration. So that means the velocity change per second is constant. The units of acceleration are, and there's a blank there. So anytime they start talking about a rate, that means you're dividing by time. What are the units for time? Seconds. So don't write this down. The units for acceleration are meters per second per second. Don't write that down because nobody writes it that way. The way we write it is meters per second squared, because having two S's on the bottom, that's like an S squared on the bottom. Anytime you see meters per second squared next to a number, I'm telling you, Caleb, that's an acceleration. And it is really worth memorizing what units go with what, because it will help you identify what's what in the questions. Oh, meters per second, that's a speed or a velocity. Seconds, that's a time. Meters, it's a displacement or a distance. Acceleration is a vector, it has a direction, but it's difficult to interpret its direction. And the reason is we tend to confuse it with velocity. The direction an object is moving and the rate at which it is changing its speed are both, and the rate at which it's moving are both related to velocity, not to acceleration. To determine the direction of the acceleration, we need to watch the object for a while, for a period of time, and see what's happening to the velocity. We're going to do a couple of questions longhand. We're going to do a couple of questions, Kathy, where we are going to go 1 second at a time, and then we're going to zoom out and ask, is there a shorter way that we can get here with an equation? So it says, fill in the chart below for a positive 1.25 meters per second squared acceleration to the east. And you can think Dakota to the east or to the right or forwards. All interchangeable. With 3 initial velocities. So let's suppose that we start out with a VI of 0. So at 0 seconds, you can all fill in 0 meters per second. And now, Caleb, with the C, we're going to step on the gas. Okay? If we're accelerating at 1.25 meters per second, meters per second squared, that means every second we're speeding up by 1.25. So after 1 second, if we start at 0, how fast are we going? Because we started at 0, in 1 second, we've increased our speed by 1.25 meters per second. That's what an acceleration of 1.25 meters per second squared means. After 2 seconds, now how fast are we going? Can anyone do the math in their head? After 3 seconds, now how fast are we going? And I wrote seconds because I'm dumb. Can we fix this one here and make it meters per second? After 4 seconds, how fast? Add up 1.25. Here's the question. After 480 seconds, how fast am I going? Do I have to calculate the previous 479, or is there a way that I can get there all at once? There is a way that I can get there. Let's come back to that. In B, we're starting off going 2 meters per second east. What would be a clever way to show east without writing the word east as opposed to west? What was a clever way to show left and right? Yeah, so I'm going to write positive 2 meters per second. So this time we didn't start out at rest, we started out moving. Whenever we clicked our stopwatch, this car was already moving. They're accelerating at 1.25 meters per second east. So after 1 second, how fast are they going now? Can you do the math in your head? We're accelerating, but positive. Yes. After 1 more second, now how fast are we going? Positive 4.50. Is that right? Yep. And you can use a calculator if you needed to, but I think we can do this decimal math in our head. And after 3 seconds, we would be going positive 5.75. After 70 seconds, how fast are we going? Do I have to calculate the previous 69 seconds, or is there a way that I can get there all at once? C is the trickier one. Instead of west, I'm going to imagine we're going backwards in reverse. What would be a good way to show backwards in reverse instead of writing the word west? So this time, our initial speed is negative 2 meters per second. What's our acceleration? Positive 1.25. Now, what does that mean? That means your car is in reverse. You're going backwards. You're slowing down because you're accelerating forwards. You're going backwards, but you're stepping on the brake. That's what we're talking about here. So after 1 second, and this is much trickier now, how fast are we going? Can anybody do it in their head? Ajne? I picked you because Alex was wrong and you were correct the first time. You said a magic word beginning with an N. Negative 0.75. Good. So after 1 second, are we still traveling backwards? Yes. Are we traveling as fast as we were earlier? We're slowing down. Ooh. After 2 seconds, how fast are we going? How'd you get that? More specific, with what? You took that negative 0.75 and you added 1 second's worth of acceleration? Okay. And so you said now it's positive, what did you say it was? Which means, by the way, somewhere between 1 and 2 seconds, we went from going backwards to going forwards. In fact, there must have been a moment in there very briefly where we were stopped. There's a lot of information contained in there. After 3 seconds, how fast will we be going? I'm getting positive, is it 1.75? If I add the 1.25 to it. And again, Dakota, the question I have for you is, what about after 119 seconds? How fast are we going, and do we really need to write a chart that's 118 long to get there? No. No. But acceleration, you can see, is different from velocity. There has to be a better way to do this. Please let there be an equation. There is. So acceleration is defined as change in velocity over change in time. Symbol, what would be a good letter to use for acceleration? A, we use a lowercase a. It is a vector, although often we'll just settle for using positive or negative to show whether you're speeding up or slowing down. Positive, you're probably speeding up unless you are traveling backwards and you're accelerating positive. Units, what did we say the acceleration units were? Meters per second is not acceleration. Yes, that's a big difference. meters per second squared, meters per second, but we write it as meters per second squared. Scalar or vector, does acceleration direction make a difference? Oh, heck yeah, acceleration is a vector. Velocity has the same symbol as speed, which is a lowercase v. If we call the velocity at the start when we hit our stopwatch vi, what does a lowercase I stand for? Initial, I'm going to use that for the rest of the year. And we call the velocity when we stop our stopwatch vf, what does the f stand for? Then the change in velocity will be vf minus vi, because change in anything is final minus initial. The same argument is for time. So we can take this change in velocity over change in time, which you could write as delta v over delta t, which I wrote right here. And then we can say that's going to be v final minus v initial over t final minus t initial. However, we get really lazy with time because time is always a change in. Over the years in physics, we get sloppy and lazy, and so you'll often see for time, I don't bother going t initial minus t, or t final minus t initial, because there's just no way to measure time without starting a stopwatch, that's your initial, and then starting a stopwatch, that's your final. It just by definition is that. So because of that, we're lazy. Where triangle is the symbol or shorthand for change in, this is worth committing to memory, but I'll repeat it often enough that you probably won't need to make a flashcard out of it. Change in anything is always final minus initial. Later on this year, we'll find the change in momentum. That will be the final momentum minus the initial momentum. Next year, you'll find the change in voltage. That's the final voltage minus the initial voltage. Or the change in force. That's the final force minus the initial force. Or the change in energy. That's the final energy minus the initial energy. Change in anything is always final minus initial. Since velocity has two aspects to it, it's a vector, so it has magnitude, speed, and direction. There are three ways an object can accelerate. The first is the one that most of you are used to, speeding up or slowing down. Your speed can change. The second one is if the direction changes. Where does that occur? Going around a corner at a constant speed. Your speed isn't changing, but as you go around a corner, your direction is changing. I assure you, you are accelerating. And then the third one is both could be happening at the same time. That's very tricky. I don't even think we look at that this year or next year. And the direction changing one, we only look at next year. All right. Runner is racing a 100-meter dash, and they accelerate from rest to a speed of 9.0 meters per second in 4.5 seconds. What was his average acceleration? Have I done the little DFIC speech with you folks or not? Have I explained what DFIC means? Thomas is shaking his head. Okay. We need some room, Mr. Dueck. Sure, kind of got some room here. I use a problem-solving approach. I use an acronym called DFIC. I haven't done this one with you. I did it with one of my classes. Haley, this is not the end-all, be-all. This is if you're frozen and you don't know what to do, here is something to hang your strategy on. I don't know how to solve this. You'll hear me say, well, have you DFIC'd yet? What does it stand for? DFIC stands for list your data, find a formula, insert the numbers, and calculate the answer. Eventually, you'll get good enough, Liam, that you'll actually skip that and you'll combine steps and you'll be doing multiple steps at once. But anytime you come to something new, I'm going to list my data. So I look at this and I ask myself, example 2, what's this question asking me to find? Acceleration. Now I put the word average in front of it. So by the way, as soon as I know what I'm being asked to find, I write that. Nick, have we written something down? Have we written something down? Yes or no? Say yes. Do I feel better? Am I more relaxed? Am I more likely to succeed? Oh, heck yeah. The blank paper staring at me is much more intimidating than I've written something down. I put the word average because I've watched runners. I don't think they accelerate at a constant rate. I think they're accelerating the most right when they leave the starting block, and later on they're not. And this is me as a nerd hedging my bet and saying, we don't have calculus. We can't deal with a changing acceleration. What we're going to find is just the average acceleration. So often you'll see the word average in front of acceleration. Don't freak out. That's me as a physics nerd, Ethan, saying, yeah, I don't think it is a constant one. I'll hedge my bets. What's that 100? How did you know? Meters. Everybody right now, here is your first physics word, and this is one you're always going to underline. Initially, you'll underline it like in real life. Eventually, you'll always just mentally underline it. It's this phrase right here, from rest. That tells me something. That tells me VI. By the way, I'll always make my lowercase I like that because in the back corner there, Robert, you might not be able to see the dot. That's a 1. That's an I. Okay? So if you're wondering why I do that, I'm trying to add a serif or whatever they call it in a font. What's VI if we're from rest? 0. What's that 9.0? What are the units next to it? Oh, so what is it a measure of? It's got to be a velocity or a speed. Initial or final? I already got initial, so. What's that, 4.5? Now, right now, this is going to seem silly because I'm going to say to you, I'm looking for an equation that has an A, a VF, a VI, a T, and maybe a D in it. There is one. Right now, you only really know one equation, and it's this one right here. Eventually, when we've gone through most of the formula sheet, when we've done most of the units, it's going to be a bit more of an involved process. But for now, so this is my D listing the data from the DFIC approach. My next step, Austin, will be to find a formula, and I'm going to write down A equals VF minus VI over T. What am I not using that they gave me, I guess, that's extra information that I don't need to solve this? D. By the way, you will learn later on, if you know the D, you don't need the time and you can still find the acceleration. We'll get there, but for now, we only got one thing to work with. Austin, what was V final? Minus V initial? All over 4.5. Actually, I can do this in my head because it's 9 divided by 4.5. I bet most of you can do this in your head. What? 2. Now, if we were doing sig figs, we would say 9.0, how many sig figs? 2. 4.5, how many sig figs? We're dividing. How many sig figs should I go to in my answer? Okay, now you ready? Listen close. How about we ignore sig figs for the rest of the year? You okay with that? Okay. And the units for acceleration are meters per second squared. Did we get a positive answer or a negative answer? Is this runner speeding up or slowing down? Yeah. Which may be Captain Obvious, but I'm telling you. By the way, here was the insert portion, so DFIC. And here is crunch the answer. I tend to put a box around my final answer. That's my equivalent of spiking the football after a touchdown. As we get more complicated, you'll actually be thrilled to put the box around the final answer because it'll have taken you 8 or 10 lines to get there. Turn the page. Yeah, we're good. The standard unit for expressing acceleration is meters per second squared. So an object is accelerating at a rate of 1 meter per second squared. If its speed is increasing at a rate of 1 meter per second each second, there is one more unit for acceleration. I don't like it, but I tolerate it because of cars. And the other accepted unit for acceleration is kilometers per hour per second. It tells you what your speed is changing every second in kilometers per hour. Why do we use that? Because what's the speed unit for cars? Kilometers per. I don't like it, but okay, here's an example. Supposing a UFO is reported as accelerating from rest. You know what? All of us right now underline the word from rest. To 680 kilometers per hour in a time of 2.0 seconds. Quinn, what's this question asked me to find? Read carefully. What is its? Yes? So I'm going to go like this. A equals question mark. From rest. What does that tell me? VI is 0? Cool. What's that 680? What are the units next to that 680? So it's a speed, and I guess it's the final speed. Now, it's kilometers per hour, and because those units are yucky, I'll write them down. I may have to do a conversion. I may divide by 3.6 and deal with that. What's that 2.0, Quinn? What are the units next to the 2.0? So, T, yes? I'm looking for an equation that has an A, a VI, a VF, and a T in it. Right now, you only have one equation, so let's write it down. It's going to be VF minus VI over T. It's going to be 680 minus 0 over 2. You might even be able to do that in your head because it's 680 divided by 2. I don't know about you. I can divide any number by 2, even if it's yucky decimals, because I'm pretty good at that part. 340? What would the units here be? The units would be kilometers per hour, that's from the speed, but then Ethan, per second. That is also an accepted unit of acceleration. I just don't like it. Here's what it's saying. Every second, this UFO was speeding up by 340 kilometers per hour. So after 1 second, it was going 340 kilometers per hour. After 2 seconds, it was going 680 kilometers per hour. Probably after 3 seconds, it's going whatever, 680 plus 340 is 1,020 kilometers per hour. So the speed of the UFO is increasing at 340 kilometers per hour each second. This acceleration might be written in the form of 3.4 times 10 to the 2 kilometers per hour per second. And although kilometers per hour per second is not the officially accepted unit for acceleration, it's often used when describing the acceleration of an automobile. Mr. Dueck doesn't like this unit, but he tolerates it because of cars. This equation here, A equals VF minus VI over T, can be rewritten in many ways. Now, some of you may have learned this silly thing that I just hate, the triangle for rewriting equations. I'm going to beat that out of you in a nice, loving teacher kind of a way because it's very limited. It only works for 3 variables with no plus or minus signs. Instead, I'm going to teach you something that will work for anything. That little triangle thing doesn't work for this because there's 4 variables. But we can't get the V by itself. I'll show you. Let's write this. A equals VF minus VI over T. Dakota, what does it want me to get by itself? Right now, with your pencil, put a little dot above the VF really lightly. I'll put a big red dot so you can see it at the back of the room. That's what I'm staring at. I'm going to try and move everything over to the other side of the equation. Here's the trick. How many of you know what bed mass stands for? Okay? When you're rewriting equations, it's reverse bed mass. You do the multiplication and division stuff first. Sorry, it's reverse bed mass. I'm going to take that back in just a second. Sorry, I totally said that wrong. For this equation, that trick's not going to work because I've got it in a weird form. Coming back to you, Dakota. That t, what's the t doing to the VF? Adding, subtracting, multiplying, or dividing? How will I move it over to this side? Dividing by t on this is the same as doing what here? So all of you right now, let's write this down. AT equals VF minus VI. Dakota, what are we trying to get by itself? What else is on the same side as the VF? A minus VI. How would I minus the VI? How would I take care of the minus VI? Yes. We get this. There was an AT. What do you say we're going to do with the VI? However, on your formula sheet, we'll write it this way. VF equals VI plus AT. In fact, this is the equation that we'll use the most. This one you'll probably end up memorizing because we're going to be using it 400 or 500 times in the next few weeks. Although it's on your formula sheet. Can you find it there, please? It is there, yeah? I think is it third line down, first equation? Okay. So do you have to memorize it? No, it's on your sheet. Will you? Most of you will because you get sick of looking it up. VF equals VI plus AT. Oh, and the reason kids kind of like this one is subconsciously all of you hate fractions. This one has fractions in it. This one does not. So it's easier to work with this one. We can also get the VI by itself. Let's look at this equation right here. How would I get the VI by itself? What's on the same side as the VI? How will I move that plus AT over? So you're telling me that another equation that comes out of here, VI is VF minus AT? We can also get the t by itself, and this is what I was getting at earlier. If you don't have a fraction, then to get things by itself, it's reverse bed mass. See the t right here? What's the a doing to the t? Multiplying, so how do I move the a over? What's the opposite of timesing by a? Divide. What's the vi doing to the t? Adding. How do I move the vi over? Which one do I do first? And the answer is here, it's going to be reverse bed mass. You're going to add, subtract first. So the VF would just drop down like a domino. You're going to subtract the VI, and the AT just drops down. What am I trying to get by itself here? What's the A doing to the T? How will I move it over? And you're going to go like this. Divide the whole thing by A. As a final equation, you'll get T equals VF minus VI over A. This equation right here has 4 variables. It's got 4 equations in one. Now you can try and memorize all 4 equations. I only gave you one of them on your green formula sheet. Chris, I'm going to suggest it's much, 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 much better if you learn and get comfortable with this formula manipulation shtick that I'm going to be preaching for the next month and a half. It drops your memorization down immensely. So I'm going to really encourage you, Paige, get good at some algebra. We are going to practice it a lot. Next page. All of us have a built-in accelerometer. Really? Yeah. Only one problem. Works backwards. Whichever way you feel like you're getting pushed, you're accelerating in the opposite direction. Really? Yeah. Suppose a car is stopped at a red light and the driver hits the gas, floors it. Which way do you feel like you're getting pressed? Which way you clear the accelerating, though, if you hit the gas? your body is a backwards accelerometer. When a car hits the brakes and stops quickly, which way does your body feel like it's getting thrown? Forwards, but you're slowing down. Which way are you clearly accelerating? You're still traveling forwards, but slowing down, you're accelerating backwards because your speed has to decrease first. So if you're ever doing a question on a test or in the homework and it asks you to talk about the direction of the acceleration, just imagine that you're on that ride. Ask, which way am I getting pushed? It's the opposite direction, I'm telling you. But you know what? I still haven't convinced all of you. How many of you been on the elevator at Playland? Okay? I'd like you to imagine it. When it shoots you upwards, which way are you clearly accelerating? But which way does it feel like your stomach is getting pushed? So you feel like you're getting pushed down, but you're clearly accelerating up. Your body is a backwards accelerometer. It can detect it. It's just always going to be in the opposite direction. When the elevator shoots you downwards, you're clearly accelerating downwards, but which way do you feel like you're about to fly? You feel like you're about to lift up and off, yes? So you feel like you're getting pressed up, but you're definitely accelerating down. Now for the $1,000,000 question. Let's see if we can do some Physics 12. How many of you have been at the Music Express ride at Playland? That's the one that goes in a really fast circle, and then the DJ, do you want to go faster? And, yeah! And they go faster and faster, okay? You're remembering that one? Which way do you feel like you're getting pressed? Outwards. Which way are you accelerating when you move in a circle? Inwards. Yep, absolutely. I have yet to find a situation where our body feels the acceleration in the correct direction. We always feel it in the opposite direction. So if you're ever trying to figure out what direction an acceleration is, put your mind on that ride in the question. Imagine yourself being there, and whichever way you feel like you're getting pushed, it's the opposite direction. I think 3 more and we're done? Good. Hoping to give you 15 minutes. Car starts from rest and accelerates at 4.5 meters per second squared for 3.6 seconds. How fast is it now traveling? Chad, what's example 4 asking me to find? Which one? Initial or final? And from now on, if you say speed or velocity, I'm going to say to you, which one? Initial or final? And that, you're just going to have to read the question and look at the timeline and say, okay, is this at the start or is it at the end? So which one? Initial or final? Yep. Everybody, let's write down VF equals question mark. Now we're going to go through the question looking for physics numbers and physics words. I would probably underline the word from rest. Chad, what is from rest? Tell me. Which initial? VI? Is 0? What's that 4.5? What are the units next to the 4.5? So what's that 4.5? What do we measure in meters per second squared, folks? Now there's another way you could figure it out, and it's because it has the word accelerates, but you're going to find in the future, I might not include that word, but you'll still know because meters per second squared means it's an acceleration. It's worth memorizing what units go with what. So let's write down, good, A equals 4.5. What's that 3.6? What are the units next to it? So, yes. Seeing why I said it's worth memorizing what units go with what? We would now say this, I'm looking for an equation that has a VF, a VI, an A, and a T in it, and it would be nice if the VF was by itself. There is one. Yeah, Third line down, first equation. VF equals VI plus AT. What are we trying to find? Don't overcomplicate it. What are we trying to find? Yeah. Oh, is the VF by itself already? If not, I would rearrange this equation rather than memorize a bunch of different versions of the equations. So it's going to be 0 plus 4.5 times 3.6. Can I do that in my head? Maybe. There's a 9 I can factor out twice. There's an 81. There's an 8.1. And then that's going to be times 5. It's going to be 40.5. And I need to double that. Is it 91? No, I got to double that again. Is it... No, I'm way off. It's 19 point something? Wow, I was way off. 16.2? Mr. Dueck. Units? It's a speed, a velocity. Meters per second. Good job, Chad. Example 5. Example 5. What are they asking us to find in example 5? Time? Let's all write down t equals question mark. What's that 110? Which one? Initial or final? Yeah. Except what are the units next to that 110? Now, if there was time in second, I could use that weird acceleration unit, but here I'm seeing an acceleration in meters per second squared. I'm going to have to convert this. So I'm going to write kilometers per hour. How do I go from kilometers per hour to meters per second? It's something to do with a 3.6. Divide. Is it divided by 3.6? How do you know? Is it on your sheet? Everybody knows where that is? Yes? So I'm going to go 110 divided by 3.6. And I get 30.5 repeating. So I'll go 30.56. What's that 8? How do you know? What does that tell me? That word that I just underlined. Everybody underline the word stop. Huh? What's V final? So physics words you're looking for are, for example, at rest. Stops, comes to rest, comes to a stop. So you're telling me V final is 0. Thomas, is there an equation that has a T, a VI, an A, and a VF in it? Say yes. In fact, it's this same equation here that Chad read to us a moment ago. It's this one. VF equals VI plus AT. What's this question asking me to find? We're going to get the time by itself. How? See where the T is? Right there. I need to take care of the A. I need to take care of the VI, but I'm going to do reverse BEDMAS. I'm going to do my adding and subtracting first. So I need to take care of this VI. How would I move the VI over to this side? Subtract. And so what you're going to get is VF minus VI. Is that correct? And then everybody else, once you've written that down, put your pencil down, look up. In my mind, don't write this down, don't write this down. I just imagine that there, but I'm imagining it in my imagination. That's why I'm imagining it. How would I get the T by itself? How do I move the A over? You know what? Everybody pick your pencil up. Let's write that. There's the equation for time. VF minus VI over A. I'm not going to memorize it. I can derive it. Now it's time to plug and chug. VF 0 minus VI 30.5 repeating all over A. Is that a fraction? Say yes. Is there more than one thing in the top? So I'll put the topper in brackets, yes. Everybody get your calculator out. And if you're not following along on your calculator, you're missing out. In every lesson, you should be following along on your calculator. Because you're going to get a weird answer here because we've made a mistake. On purpose, for me, very subtle for the rest of you. When you type this in, when you go bracket 0 minus answer button, I'm going to use my answer button because it's stored on my calculator, divided by 8. What do you get? Huh? Time can't be negative. You got a negative? For a candy, can anybody see the mistake that we've made? Yeah. Are we speeding up or slowing down? Slowing down. We're slowing down. It should be divided by -8. Now the nice thing is all of you got the same magnitude as me for time. You got 3.81. I used my answer button. If you used 30.54 and rounded off, we might be different on the last few decimals. But all of you got the same answer as me, but you had a negative there. So if you get an answer that looks weird, Caleb, for time, go back and check your values. The universe is saying, dude, you're telling me somehow that you were slowing down and speeding up at the same time. I can't do that. $3.82. Last one and we're done. Ethan, what's this question asking me to find? Yeah, one of the things I like about physics is it's not like the word problems in math, because in math, the word problems that they throw at you, half the time you don't even know what they're asking you to find. What do I let be X? In physics, it'll usually be pretty obvious because it'll say, what is the, or find the, or tell me the, or something like that. So, A equals question mark. Everybody underline from rest. What's that telling me? Ethan, what's that telling me? Yes. What's that 37.8? What are the units next to that 37.8? So it's a velocity. Which one? Good. What's that 2.1? Looking for an equation that has a VF, a VI, an A, and a T in it. There is one. It's the first one on the third line of your formula sheet. It's that one. Except we want to get, what do we want to get by itself? The A. How would I get the A by itself? I'm going to do reverse bedmass. The T is multiplying. I'll do that later. The VI is adding. How would I move the VI over, Ethan, my friend? So the VF is going to drop down like a domino. There's going to be a minus VI, and that would leave me with AT. How would I get the A by itself? What's the T doing to the A? Adding, subtracting, multiplying, or dividing? So I will. Sorry, what's the T doing to the A? It's timesing. So I will divide it over. Yeah, I figured that's what you were getting at. So are you saying like that? Here's my equation. Let's see if this works. 37.8 minus 0 divided by 2.1. 37.8 minus 0 divided by 2.1. I probably didn't need to type the minus 0, but if there was a number there, that's how I would type it on my calculator. Do you all get 18 meters per second squared even? Sorry, yeah, that's the acceleration. Later on, you'll learn that's just under 2 Gs. But you don't know that yet. What's your homework? Let's see. I'm going to go skip number 1, number 2, number 3. Number 5, number 6. Eight is cool. Skip 7. And have you been on California Screaming at Disneyland, California Adventure? These numbers are accurate. Number 9, you've wondered what you're accelerating at? Now you know. I'm going to go with 13, 14. I'm going to do one from back here to 10 or 11. 10 or 11. I'll go with number 10. Okay. We need to practice this a little bit. Next class, we're going to be putting everything together. I'm going to be introducing the 4 equations that we're going to be using for the next month. And that will allow you to find all sorts of stuff. Then we're going to talk about free fall. We're going to talk about G's and G accelerations. And we're in some interesting stuff. Today was mostly teaching stuff.